So we have a formula in probability theory that helps us calculate a probability when we're given some information, right? Because probabilities change when you're given information. Like if you're given information that a driver is intoxicated, that certainly increases the probability that an accident's going to occur, right? So that's a conditional probability. So the probability of some event A, given that some event B has occurred, that should equal the probability of A and B, that's what this simply means, and, divided by the probability of event B. Okay, so in this example, there's two primary events happening. A person could be telling the truth, or they could be lying, right? That would be A complement. That's just our shorthand notation that means the opposite of event A. And then the lie detector test, you could fail the test. Actually, it makes more sense to say like this. You could pass the test, that could be event B, or you could fail the test. Okay? So you could tell the truth, you could lie. You could pass the test, or you could fail the test. So let's see. In the third sense here, let's go through the word problem, take the sentences, convert them into some symbols or maybe some equations to help us solve. Okay. Suppose that in a lie detector test, 65% of lies are identified as lies. So we sent somebody in. We said, you're going to go lie to this lie detector test. Okay, that's information that we know. We are given, so that the given part of the formula comes after this vertical bar. Okay, we're sending somebody in. We know that they lie. That's given information. And the probability that the lie detector test identifies them as a liar, so that would be failing the lie detector test. So the probability of identifying somebody as a liar, given that they are a liar, is 0.65. And then 14% of true statements are also identified as lies. So we're sending somebody in. We're given information about the person we're sending in. It's not a question of whether they're telling the truth or lying. We know that the person going in there is telling the truth. And the lie detector test fails them with a probability of 0.14. And then the third piece of information we're given is that suppose that 93% of the job applicants tell the truth. So the probability of telling the truth is 0.93. So that's all the information we're given in the word problem. Let's see what they want us to do. What is the probability that a person who fails the test was actually telling the truth? So we are given that a person has failed the test. What is the probability that a person fails the test? That's B complement. Given that the person is, what is the probability that the person who fails the test was actually telling the truth? So the probability that a person was telling the truth, given that they failed the test. That's the probability we're asked to calculate. So if we write this out with this formula, it says that it's the intersection of the two. It's A and B naught divided by the probability of the given event. So divide by the probability of B naught. So if we look at what we have, we don't have this and we don't have this. So that's why this is kind of a tough problem, because we got to go do some investigation to find out these other events. So we might be able to find this one pretty quickly from this event. Okay, and the reason why I'm saying that is because I know that it's going to be B complement and A in the top part of the formula. So if you write this out, this is the probability of B complement and A divided by the probability of A. And that's supposed to equal 0.14, right? So I just took this and rewrote it with how the equation says to do. And actually in here, instead of the probability of A, we're given that. It's 0.93. So that's a quick equation to solve. You just have to multiply 0.93 to both sides. So the probability of B complement and A, that's going to be 0.93 times 0.14, 0.1302. So that's the top part of the formula. Now, we don't have this, and it doesn't look like we're going to get it anywhere, right? Because the only place in this formula where we have just one letter by itself is in the denominator. Well, here we have A complement in the denominator. Here we have A in the denominator. We don't have B, we don't have B complement. So we have to actually use we're going to use that top equation that we haven't used yet, I think. But in order to calculate the probability of B complement, we can use some logic to make our own equation. The probability B complement is failing the test. The probability of failing the test is equal to the probability of failing the test and telling the truth plus the probability of failing the test and lying. Okay, and so I didn't come up with this from the textbook or anything like that. This just comes from logic, right? The probability of somebody failing the test is the probability of somebody failing the test and telling the truth plus the probability of somebody failing the test and lying. There's only two options. You can fail that test if you tell the truth, like this. You can fail the test and tell the truth, like this circle says, or you can fail the test and lie. If we add those two probabilities together, then we've got the entire probability of of failing the test over here. Okay, and so this one we have, that's 0.1302. This one we don't have, but we could get it from this formula. I kind of ran out of room here. It's kind of messy when I erase. But we can get this from this top formula. The probability of B complement and A complement, that's 0.65. That should equal the intersection of the two, B complement and A complement, divided by the probability of A complement. So we know what this is, because if the probability of telling the truth is 0.93, then the probability of A complement, in other words the probability of lying, is 0.07. And the probability of B complement and A complement, that's something we can solve for. So if you solve that equation, that means you need to multiply 0.07 to both sides. So we found that the probability of B complement and A complement is 0.0455. Okay, so we finally have, remember this is the thing that we're trying to solve for right here. We had this from the second equation. We just found this. It's adding these up. 0.0455 plus 0.1302, that makes 0.1757. So now if we divide these two probabilities, we'll have the answer to the question that they're looking for. The probability that someone was telling the truth given that they failed the test. So it looks like there's a roughly 74% chance of that happening.